Hello, I'm Mouse. I'm talking about mapping imaginary cities, which are procedurally generated. I'm going to save some time for questions at the end, so feel free to use the sli.do app if you have questions during the talk. So this is the first thing that I saw when I got off the plane, because I pulled it up on my phone. Maybe you did too. This is St. Louis. Pretty cool. But this is not St. Louis. This is a screenshot of Google Maps that's being projected on a screen. I know, I'm blowing your mind. Bear with me. This is a map. Pretty cool. And this map is informative. It tells me some things about St. Louis that I didn't know. Like there's a place called Venice and Brooklyn and Dutchtown. That's cool. And it's useful. It really helped me figure out how to get from the hotel to or from the airport to my hotel. But this map is not complete. No matter how long I look at this map, I'm still not going to know that much about St. Louis. And it's not value neutral. This map was created by a whole slew of cartographers and designers and programmers, etc., who all came in with their own personal and professional worldviews. And it's also created by Google, and Google has its own agendas about what it wants to show me. So to quote the critical cartographer J.B. Harley, maps are never value-free images. Except in the narrowest Euclidean sense, they are not in themselves either true or false. So maps are not neutral. They have stories to tell, and they have agendas. And in his essay, Harley goes on to say that he views maps as a kind of language. And even if you don't leave this talk like really excited about making procedurally generated maps, I hope that you at least leave excited about reading the maps in your life more critically as kind of literature that has authors and agendas. So back to Google Maps. Here's where I live. This is San Francisco. And we can see what Google is prioritizing. Like we've got all the streets here so I can navigate. When we've got all these points of interest that may be relevant to me. And like really to me, I'm logged in when I took this screenshot. So we've got my oral surgeon where I got my wisdom teeth out. We've got my office, my friend's office, my favorite dumpling place, which are all points that you wouldn't see as just a casual user unless you looked for them. But there's also a lot that this map isn't showing me. This is certainly not all of San Francisco or all that's relevant to me. For example, here's a map of coyote sightings during the day and during the night in San Francisco. And Google's certainly not showing me this by default. And it might be interesting to me because I actually encounter coyotes pretty often, weirdly. It's also not showing me the indigenous people who inhabited this land before it was colonized and who are still around to some degree. And like, what were their names and what were their languages and where do they live? This is from Rebecca Solnit's Atlas of San Francisco, Infinite City, which is fantastic. And it's not showing me super fun sites. All of these pink dots are places where there is serious industrial pollution that is still being cleaned up. Pink is in progress, red is not started, and there's one green dot for already cleaned up. If you see that cluster of pink dots at the bottom there, that's where I grew up, so that's cool. Sure, that's fine. This is a really interesting historical map. In 1854, there was a serious cholera epidemic in Soho neighborhood of London, and the physician John Snow was trying to figure out what the source was, what was causing it, so he could stop it. And so what he did is he took a map of the area and he went around and he put one of these black rectangles that you can see here on every spot where he found a death from cholera. And it's a little hard to see because it's all black and black, but there's a lot of black rectangles right in the center of the map, and that's where the Broad Street fountain is. And so using this as a way to like visualize that data, he determined that the Broad Street fountain was the contaminated water source that was causing this epidemic and was able to stop it. This is a similar map. It's using little icons to show you where incidents occur. It tells you something pretty interesting about where you might find Bigfoot. So these previous maps have mostly been using symbols and points on a map, but we can also communicate a lot using color and shade. Here's a topographical map of San Francisco, which is pretty interesting to me because I ride a fixed gear bicycle. And And this map is telling me something really specific, but it's in and of itself a pretty politically neutral message. It's just saying, here's what's high and here's what's low. But maps can be very politically minded and have a very clear agenda. This is another map from Infinite City. And Rebecca Solnit in this map is trying to make an argument that the Bay Area is a military conservative brain trust. And so she selects all these locations that are like military sites or corporations with military contracts or conservative think tanks and points out their connection to conservatism. And so she's making an argument with this visualization that maybe the Bay Area isn't so liberal. But you can use selections, or selection is interesting in a map even when it's less like clearly saying something really, really opinionated. This is a map, this is the first known map of a city. It's extremely ancient, it's from 1400 BCE, and it's of the Babylonian city Nippur. And what's really cool about this map is that it's all labeled in cuneiform, and we can translate it, so we actually know what they're pointing out. We've got a canal here, we've got a ziggurat, or a big orchard, beautiful gardens, the Nana Gate, and the Gate of the Unclean Women. And so by looking at what is in this city, and also what the cartographer who made this map chose to highlight, we can get a little bit of a sense of what it was like to be in this place. Like, we can understand like the fortifications and what it was like to get in and out of this city, what the irrigation was like. We have a sense of these green spaces that have been created, and maybe even like a hint about something about gender happening. It's definitely not, a complete story, and there's a lot more to be said about life in ancient Babylon, but this map tells us a lot, and it's really exciting to me that we can translate it. Maps can also lie. This was created by a company that was concerned about their intellectual property. So they put this city, which is highlighted in green, or town, I guess, Agloe, New York, on the map. And they just put it there, even though it's not real, so that if somebody else made a map of the Catskills and it had Agloe, New York, they would know that they had stolen their data rather than doing original research. This is called a trap town. You often also see trapped streets, where maybe somebody adds a little alley in the corner that isn't going to like confuse anyone too much, but they'll know if somebody copies it because it's not a real alley. What's really interesting about Agloe, I think, is that some years later, somebody built a general store in that area, and they named it Agloe General Store because it says it's Agloe. And since then, the store is closed, it's been removed from the map. But I like to think that for that period of time, Agloe was brought into existence by this map and by this cartographer. Here's another map that's not telling us something pretty important. It looks like a pretty innocuous topographical map of a place in Russia. But if we go and look at the satellite image, we notice that there's something pretty interesting up there that they don't show on the map. This is the Krasnodar RSDN20 transmitter, and it was censored from these maps to keep the location secret. So of course, I want to talk about maps of places that aren't real. This one is very close to my heart. It's maybe the first fictional map that I consumed. Maybe that's true for you as well. It's a map of Middle-earth from The Lord of the Rings. And this map has the locations that are important to the book on it, and we could track the journey of the hobbits, and so it tells us a lot about the story. And it also has a form factor that tells us about the world. Like, it looks like it's written on parchment with a quill pen. And if you imagine this map with the same information on it, but presented like Google Maps, and you didn't know anything else about Lord of the Rings, you would have a really different sense of what that story was like and what that world felt like. This is another fictional map that I really love. It's from the 5th season by N.K. Jemisin. The map was created by Tim Paul. Yeah, it's an awesome book. I really recommend it. What's interesting is that in terms of information hierarchy, the biggest thing after the title of the map is these tectonic plates. And that's definitely not something that Tolkien showed on his map. But plate tectonics and earthquakes are really, really important to this story. And just by looking at this map, we're able to see that there's something going on there where this is a point of interest. So in terms of creating procedurally generated or just fictional maps in general, I want to think about the different viewpoints that go into it. And there's the creator's viewpoint. So there's all of my preconceptions and the research I've done, my idea of what a city looks like, what a map should look like, how streets are laid out. And then there's also the fictional mapmaker, the kind of the narrator within my story. Like, who is this person and what is their relationship to the territory that they're mapping? Do they live there? Are they a foreigner? How do they feel about the people who are there? Are they a colonial force? And then there are the people who live in the map. What are their agendas? How do they want to be presented and viewed? And how do they build their city? What kind of structures do they make? How do they plan their roads? What languages do they speak? And then, of course, there's the actual viewer who's going to look at it, who maybe doesn't speak the fictional language, and what information do they want to try to understand this fictional place? So my project, I decided to make tourist maps, and I wanted to have a sense that it's made by kind of a big corporation that isn't, it's not like one of those adventure travel places. It's very like, stay in a nice hotel and everything's gonna be great and shiny and you're gonna have fun and be beautiful. But I also wanted there to be a little bit of an undertone, like a side note that maybe everything's not quite as shiny as it's making it out to be. And I'll let you decide how well I've accomplished that. But I like to think of a map as a model, and the process of making a map is the process of modeling. And models are inherently incomplete. And this is really, really good because it means you can ever finish. And if we could make a model that perfectly represented what we were modeling, it would raise a lot of really disturbing philosophical and ethical questions also in terms of pocket universes. So you have to think about the constraints that you're going to use in your model. And I always think of this quote by my friend Darius Kazemi, who said, all the stuff I make as stupid as possible. And I really try to live by that. I don't always, but I really strive for that. And so I'm going to talk about the algorithms I used, but keep in mind that they're not always the most modern algorithms, they're not always the fanciest, and they're not always the most accurate to how the world really works, but they were the easiest to use, that got and the simplest, and they got me the results that I wanted, and I think that's a good approach to picking algorithms. But I encourage you to look into the fancier ones because they're also neat. So I approached my map in 3 kind of main layers. There's elevation and topography, and then population, and then roads. In reality, there's a lot more data, but those are the 3 main ones, and I'll go through these. So we'll start with terrain. I use simplex noise to generate terrain. Simplex noise is like the new and improved Perlin noise. Not to hate on Perlin noise, that algorithm won an Oscar, which is more than most algorithms can say. And so simplex noise is a little nicer. It's a little less computationally complex, and it looks a little better. It has fewer directional artifacts. And what this is I'm not going to explain how it works. It involves lots of matrices and complex stuff that is interesting, but I'm not going to get into because there's lots of libraries that do this. But it's pseudo-random gradient noise, so it creates really smooth transitions between areas of light and dark or high and low values. So on this visualization, black is 0 and white is 1, and there's values between there. But this does not really look like a map to me yet, even though it does have a compass rose and a little scale. I had a cartography professor in college who would it was like the golden rules, you never ever allowed to turn in a map that didn't have a scale and a compass rose, and I guess that really stuck with me. So let's just put nicer colors on it. I stole these colors directly from that topographical map I showed you earlier, because I thought it was pretty. And then I've just bucketized the values to these colors, and then I'm also going to put little like gray lines when it changes over from one bucket to the other to make it kind of look like a topographical map. So we go from this to this. And already it looks a little more like a map. It's a little more exciting. What's cool about simplex and Perlin noise is that it's really easy to tweak it. So one thing you can do is you can change the amplitude. And I did this using an exponent to keep the value between 0 and 1. So when you raise a value that's below 1 to a like exponent that's greater than 1, it'll increase. So this is sort of inverse amplitude relationship. But basically, if we raise n, we can go from this map, which has all these different scales on it, to this map, which is a lot lower. And maybe that's nice for a city, because we don't always build cities on the hilliest place in the world. Tell that to San Francisco. We can also adjust the frequency of a map, and this sort of like zooms in and out of the map. And you do this by just multiplying the x and y coordinates that you're using to calculate the noise by a certain constant. So I'll show you in one dimension. We have this line, which we can imagine was created by a noise algorithm, and not just an Inkscape. And then if we change the frequency, the red is our original curve, just a little smaller, and now there's more data, and it's a little more up and down. So in 2 dimensions, we go from this map to this map. And you can see there's the same features, but there's a little more going on. And then I think this is the coolest thing you can tweak. This is octaves of noise. And this adds roughness to the gradient, because if you use simplex noise kind of like right out of the box, it's very, very smooth, and that doesn't feel like how organic forms are. Like they've been subjected to construction and to erosion, and there's just a coarseness that we want to emulate. So to add octaves, we just keep adding noise, smaller noise, onto the noise we already made, so it becomes fractal noise, and you just keep decreasing it. And so again, I have our one-dimensional example, and we can just imagine that now it's a little bumpier. So for our 2-dimensional, we go from here, maybe to here. And the value, the like 248 that we multiply our frequency by, is called the persistence, and that just affects how much impact that octave has on the overall result. So I'm pretty happy with this map. Actually, this one actually already has a couple octaves applied to it, and so that'll do. So I'm going to use this to go forward, but it's, like I said, not a very interesting map. So let's add an ocean. And I did this using midpoint displacement. So all I do is I pick a start and an end point, say this is where the coastline starts, this is where it ends, and draw a line between it, which currently not a super realistic coastline. I mean, So I draw a perpendicular line to it that's a certain length, and you can see it's skewed down. There's less above the line and a little more below, and that's because I would rather have the coastline move towards the edge of the map so there's more land visible to the viewer. And then I just look on this segment and find the point of lowest elevation, because that seems sensible. We maybe want the coastline to follow the lows in the map. And then just move the line, divide it into 2 segments that touch that point. And then we do this recursively. So our 2 new segments, we make a little smaller line and move the line to there, and just keep doing this and keep doing it until we have this nice kind of organic feeling coastline. So everything that's in this kind of funky shaped quasi-triangle, that should be ocean now. And so we want, instead of the regular hills, we want this to all just like slope down into the seabed. And I'm going to set the water level, the sea level, to 0, and everything below 0 will be underwater. So this is pretty simple. I just calculate the distance from any point that's within our new ocean area from the coastline, and then I decrease the elevation of that point proportionally to the distance. So I did distance squared over 10,000, and I just fiddled around with different numbers until I got values that I thought looked nice. That's true of a lot of things on this, actually. So when we apply that, we get areas that are now underwater, which is great. And you can see that the coastline is kind of the wrong word for this, because it's not actually where the coast is, it's where we start going down into the water. And because we're going down really slowly at first, it's still going to be values greater than 0, so they're still going to be above water. So we have this kind of like sloping beach, which is nice. And then here it is. Already looks a little more like a real map. Excuse me. So I'm excited about water features now, and I'm just going to keep adding water features. So let's add rivers. I tried doing midpoint displacement for rivers, and it made really boring rivers. because midpoint displacement never kind of curves back on itself, just by nature of the way the algorithm works. So instead, I just put a point, I got a point in a direction, and then I look ahead from that point. I've put a few points already just so that it's on the map, but this is how they were all created. So I look at the angle of the 2 previous points, and then I make an arc of 2 pi over 3 radians, and just, those are my options. And so I pick the point of lowest elevation because I want the river to follow, the low points on the map. So I've picked this point, and then I just keep doing this, and you can see it's following this valley, which is nice. But it's also kind of going uphill because this is not actually realistic terrain, and I wanted it to do this because otherwise it would never get anywhere. It would just make a little lake. So it's following the lowest point available to it, not the lowest points overall. And we just keep going until we hit the ocean. And then I don't show this, but I use midpoint displacement between these points to make even more granular shapes so it wouldn't be too jerky. And then I did the same thing I did with the ocean, except kind of in reverse. I just calculate the distance from the center of the river and make it lower in the center and less elevation change, so it's closer to its original elevation further away. And now I have a river. So as an aside, I tend to write code that has bugs in it. I don't know, maybe you do too. But what I learned in the process of doing this is one of my first sojourns into doing visual generative stuff, is that visual bugs are awesome. They're way more fun. So I'll leave it to you to consider like the social and ecological conditions that led to this map forming. That was fun. So now we need people. People should live in this place because I'm trying to make a city. And to do this, I used 2 different scales. I used this just higher in the center. This is just an absolute value function. So the dark blue means a higher number, closer to 1. White is 0. Because I want people to tend to live towards the center of the city. And then I did another round of simplex noise, just really simple, no octaves. So, because I don't want everyone to actually live directly in the center of the city. I want there to be, neighborhoods and distributions and an organic feel. So I multiply those 2 together. And I get this map that tends to have people living towards the center, but they're still in clusters. Basically, they form neighborhoods, which is really great. And now I want to define what those neighborhoods are. So I got the local maxima of this map. And then I did a Voronoi diagram. And a Voronoi diagram divides a plane into regions or Voronoi cells or neighborhoods based on the difference between sites, or in this case, local maxima, that are on the plane. And there are a lot of really cool ways to calculate the position of Voronoi cells. They're really efficient ways, really clever ways, but the really down, dirty, simple, easy to understand way to figure out where Voronoi cells are is you just say for any point, any coordinate, it belongs to the Voronoi cell of the closest site. So you can just look at all the sites, figure out which one's closest, you got it, that's your neighborhood, or that's your cell. So that's what I did. And now I've got these neighborhoods. There are local maxima that are off-screen because this map's a little wider than the presentation, which is why there are cells on the sides that don't look like they have sites on this map. And so for my next step, I wanted to add a little bit of parks and beaches also to give a little bit of livability to my cities. I did this in a little bit of a slapdash way. It's something I want to refactor, but it worked well enough. I just said if the population density is below a certain threshold, which I can adjust, or it's above, or the elevation is above a certain threshold, that means it's a park. And I can change those thresholds so that there's more park area or less park area, depending on what I want from the city. And then I also said, our coastline is not really at the water, so everything between the coastline and the water, let's call that the beach. So now we have something that looks kind of like a map, also kind of looks like a Rorschach test. It's missing something really important, which is human structures and roads. I tried a lot of different things in making roads. There are a lot of academic papers out there from the games industry and so forth about how to generate roads. I read a bunch of them and I found them all really confusing and not that useful. Sorry if any of you are listening. I'm sure they're great for other people, but they weren't useful to me. So after a number of false starts, some of which were more ominous than others, I settled on this system. So you start at the city center, and I create a really small, like 1 pixel line segment that has a direction, just to kind of seed my map. And then I propose continuing that segment forward at in the same direction for another unit of a given segment length, which is adjustable. And then I look around within a given arc, kind of like I did with the river, to try to find the point that'll be most level, because I want my road, if possible, to be as flat as it can be. And so this is the perturbation value. It's a pretty small arc. Well, it's adjustable, but much smaller than for the river. And then, now we have a proposed point here, and we have to evaluate if it's acceptable. So it has to be on the map. It has to not be underwater. And if it's in a park, I reject it 40% of the time, just so that there are fewer roads through parks, but no roads through parks. And then the segment length has to be greater than the minimum segment length that's set, just so that recursion stops eventually. So this segment length, this little segment proposal passes, so we're going to keep this one. And then we're going to fork off from either side of our original segment. Pretty similar, except the difference is that the segment length is changed by between 50 to 110%, and that keeps it a little variable, but by and large, the segment lengths are getting smaller as they fork off from the parent. And I use a smaller perturbation value, half as much, just so that there aren't really, really acute or obtuse angles. So here's our 2 forks. They've been accepted. They're both good. And then we do this recursively. We treat these new endpoints we've added as our origins, and we fork off and continue from them. But something interesting happened here. These 2 lines connected. And this is really important. So when a segment is proposed, it checks if the endpoint is within a given radius of some already existing accepted endpoint or start point. And if it is, it moves the point that we proposed on top of the existing segment. So as a little bigger example, let's say this is the dotted one is our proposed segment, and the solid line is our existing segment. It checks they're in the same radius, so it just moves our proposed segment to connect to the existing one. And this is really, really important, because without this, you just end up with this labyrinth of dead ends, and no streets ever connect to each other, and it's not terribly traversable as a road network. So that's great. And then we just keep doing this, keep doing it. And another nice thing happened. We made a bridge. So when a point hits water, it doesn't reject it outright. It goes to an edge case, and it tries to decide if it wants to try to make a bridge. And this is correlated to the population density, so that there tends to be bridges built where people live. So if it accepts that, it'll try to just make the point a little longer to get to land. And then the segment direction is shifted so that it's perpendicular to the river, just to make it look a little more realistic. So now we have bridges, which are very useful. And we just keep iterating on this until we have a whole bunch of roads. This is also really adjustable. I've changed the perturbation level for this map to be really, really low. And now I have a map that's much more of a grid. It feels maybe more like a modern pre-planned city. Or I can make the perturbation really, really high, and it's even more curvy and weird, and maybe feels like a city that was built more organically. Maybe it's a little older. And then we can also adjust the segment length just to change the road density. This is the longer minimum segment length. And just gives you a different feel of the city, but pretty happy with this map. So the next step is just to add some actual points of interest to it. So I generated a language. That's one step. And so I used my language to name all the neighborhoods and to name the city. And put some restaurants, we've got a tea house and some interesting sites onto my map. And then I put it into the context of a kind of whole tourist guide, or maybe like tourist pamphlet guidebook. It's a little long. And so we've got, our beautiful photograph of our city and the weather right now, some information about the region. I'm really proud of the 7-day forecast. That's like, no question, my favorite part of this project is that you can get a weather forecast. And now we have this beautiful interactive map, and we've got this tea house that everyone loves, this restaurant that not so much loved, and we have this temple here devoted to the god Izuer, who is a winding river with a tuft of grass's head. And the locals like to leave sacrifices of teeth behind, and I'll let you ponder whose teeth those are and where they come from. And just some more information about our city, something about the language and the wildlife. Yeah, and so that's what I did with these maps. Okay, I got one question. Thank you. And that is, what software programs did I use to create these maps? Well, I wrote it all in JavaScript, which I regret. But here we are. It's too much work to go back now. And then I rendered it all in P5.js, which is a really cool library. P5 is awesome, thank you. It was really good for making these like skyline images. It wasn't an amazing fit for the maps because I didn't really use any of the features to make it cool, like that it's like browser native. This is actually just like a static image of the map, whereas this is a rendered P5. Like I rendered it in P5 and then exported the canvas. So I could have really done that in any like graphics library, but P5 is really cool and it's what I used. It's very easy to use and I recommend it. Yeah, and I think the only other library I used was a simplex noise generator. I use seeded random a lot. Seeded random is great. Yes?
Do you know the book Alfred Korzybski? It's basically a collection of papers on procedural generation.
No, but it sounds fantastic.
It's really good.
Yeah, I'll look it up. I'm sorry?
Repeat the question, please.
Has she heard of the book Algorithm Beauty of Cities?
Yeah. So I have not heard of the book Algorithmic Beauty of Cities, but it sounds awesome. Yeah. Yes?
What books did inspire you?
So the question was, what books did inspire me? Gosh, I've been thinking about maps for so long, I haven't thought that consciously about it. I took an archaeology class in which we read The City in the City by China Miéville. Yeah, and the story itself didn't stick with me that much, but the concept, there's two cities that like are co-located but mutually exclusive. Is weird and very interesting, and that really stuck with me. Definitely Rebecca Solnit's atlas, Infinite City, was a really cool like look through just different ways of presenting the same space and with different agendas and different perspectives. There's the essay by J.B. Harley that I mentioned, Maps, it's like Maps, Power, and Something. It's wonderful. It's from a bigger collection about landscapes. It's pretty interesting. But his essay is really fantastic. It really breaks down the ways in which maps can be used for propaganda and to reinforce like existing power structures. It's really worth reading. It's pretty short. Yeah. Yeah, it's all on my GitHub. The map repo is called Maps, very creatively. All of the code for this city generator is also there. The language generator is there. Sorry, it's kind of messy, but.
Have you thought about taking existing city maps and starting from that and modifying
Yeah, I considered that when I was approaching this project. I ended up not doing it because I was excited about generating my own terrain. But I think it's a really cool idea. I think it would be a little bit of a different project, which would also be really cool. So I do think that's a good, sorry, the question was, did I consider using existing city maps and modifying them? And the answer is, I considered it, and I think it'd be awesome, but for a really different project. Yes. Oh. Well, go for it. Yes, I have a little tool that generates, procedurally generates languages. Yeah.
I was wondering if you try using like maybe simplex noise to as a source map for the perturbations, so that some of the neighborhoods would be more grid-like, some would be more organic.
Yeah, that's one of the things I have, I think, in a branch on my laptop. I've used the neighborhood, like certain neighborhoods can have different perturbation levels, so that maybe like one feels like it was planned a little differently than another. So yes. Yes, in the back. For a what? Have I considered running simulations of this for a city planet? No, I really, like I said earlier about models and constraints, I really limited myself to the scope of a city, and I don't think it scales very well. So if I tried to make this into multiple cities, it would look pretty funky. And if I made it into an entire world, well, I mean, the real limitation is that my code is pretty inefficient, and it would take too long to run at a planet scale. But it's really intended to be used at this size. Yes?
Have there ever been any, because like I'm sure this is really simplex noise and stuff like that is commonly used for like video games and stuff like that. Has there ever been any actual statistical studies on how correlated that is with the real world?
I don't know. I think there are more realistic algorithms. I know the diamond square algorithm, I don't know if that's more realistic, but it's another approach, or using Voronoi cells and changing the elevation that way are different approaches. But I'm not aware of any studies specifically, though they might exist, about how realistic simplex noise actually is. Yes?
You generated population density and the roads. Consider simulating traffic to see how traffic would affect the roads as well as the population.
So the question is, did I consider simulating traffic to test my roads? The answer is sort of no, sort of yes. I looked at a lot of different approaches in general to mapping, and some of them are really simulation-based, and they're really, really cool. Like, there are ways of mapping terrain where you just basically let erosion take place over the terrain you've generated to make it more realistic, and it's awesome. Or like actually having traffic models to create your streets. And I decided that was too much work for what I was trying to accomplish. But, yeah. Yes?
What was the mechanism for altering the width and size of the road? Because they are sort of
Yeah, so that happens, there's a set like starting segment length of a certain number of pixels, and then as it forks, it gets a little smaller, or mostly smaller. And then also as the roads snap together, the length will change. So there's just a little bit of like chaos introduced to the road length, both by like calling random and also by connecting roads together. Yes?
What other agendas do you think would be fun to generate maps for?
I would love to do the perspective of like a kid who lives in this city and have like kind of like a hand-drawn map that shows maybe the spots that are important to that kid, which are really, would seem really like uninteresting or trivial to somebody else. Like, you know, this is my favorite boulder. I think that would be a really interesting perspective to show. I'd like to make that. And it would be interesting to look maybe from, to look kind of politically at like the conflict maybe between like an official map versus an indigenous map and what that would look like in a space. Yes?
Consider generating by changing population over time and then growing roads structure.
Yeah, so the question was, have I considered modeling it by changing population over time? The answer again is that, like all other simulations, I decided it was too much work. But I think it's really cool, and people have done really interesting work doing maps over time that I've definitely read papers where people have done that, where they've produced really interesting results, and I think it's worth doing. Yes?
It looks like you had multiple cities at the end of this process. I'm
Yeah, so the question is, how do I like curate which cities I decide to keep after one is generated? The answer is I actually pretty much keep all of them. It's like this generator is pretty reliable. I'll in advance, I'll set the presets how I want. So I generate the data about the city first. And so I'll know, like, should this city have an ocean? Should it have a river? And then I'll turn on and off those features. And I can set the perturbation or randomize. And it usually, like, it's pretty consistent. I'm usually happy on the first pass with what I've got. All right, I think that's my time. Thank you so much.